So let's start next problem. In mass spectrometry, we are on genesis of that alkane functional group, and we discussed pentane. Next one is or here that pentane is given another way. You can write in this way also by showing dot arrow and single headed arrow by radical type. So let's look. So in this another way, it is also written that genesis of pentane like this. So this is pentane, which is your molecular ion showing M by Z 72 here. So you are getting plus and dot. So plus it's written on that whole compound, and dot is given between carbon and that hydrogen bond. Okay. So breaking up this carbon-carbon bond. So this carbon one electron bind with this CH bond to make the CH2 group, and one radical is going to CH2. So you're getting CH3 dot, and this CH bond retained due to gaining of one electron. So two electron, that is a bond formed there. So you are getting butane with positive charge. So what is a M by Z for butane? Calculate it just fast, because in exam you have to calculate that ch2 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 plus means how much m by z. So how it is calculated? So count carbon, total count, carbons, total hydrogens or oxygen others. So just count it. So you're getting C4H 9, C4H9, and C4, that is 48 plus 9, you're getting 57 for this. Same way you can lose that CH C2H4, that is ethyl. You are getting next fragment is M by Z equal to 29 here. So in this way you can show or breaking of this CH2 and CH2 middle bond. So first M by Z form in this carbon hydrogen bond. So where it form, we don't know. You have to show any bond, either it is carbon-carbon bond or carbon-hydrogen bond, lose one electron. It is unknown for us where from electron loses when ionization takes place. So one can show positive with dot of this carbon hydrogen. Then breaking of this carbon carbon bond, one electron goes to that CH bond formation and one electron goes to breaking for this ethyl group. So you're getting ethyl radical plus this CH3 CH2 CH2 plus positive charge. So mass of this is that mass, yes, mass of this is a 43. And from this mass, you if you lose this by breaking of this CH3 CH2 bond, positive double headed arrow, that is breaking up CH2 CH2, then you will get this CH3. So loss of ethene molecule, CH2 double bond CH2, positive charge shifted on this because you are breaking this bond to making a new double bond. So you're getting positive charge shifted on CH3. In the same way here also, this shifting of this bond towards to middle of that make for making of ethene with CH2 positive. A loss of minus 28 from that 57, you will get 29 peak, or minus from this you will get 15 for this fragmentation. Yeah, one can show like this or one can show previous one, which is easy, you can write in exam. But you have to show all fragment peak, that is a values given. You have to show each fragment for that value. Next example is hexane. So hexane M by Z for its molecular ion is a 86. So breaking of CH3 radical and H, this CH2 positive, you're getting loss of, so 15 part is a 71. So 86 minus 15, you're getting M by Z 15. Then from same that species or that positive charge, this middle bond is shifted, that is this bond is break and make a CH2 CH2. So breaking takes place with shifting of this two electron. The positive charge will goes to this carbon, you are getting 43 mass. Okay, and from 43 you are go again loss of CH2 CH2. There is a, this bond will break, will go to making of double bond, and you will get CH3 positive. So you are getting 15 charge, 15 charge particle fragment, that is the methyl here. So from parent you are getting, this is parent molecular ion peak, parent to dotted, this first dotted, from that dotted to second daughter, and second daughter to third daughter you can make. So from molecular ion peak you are getting daughter peaks, and daughter to daughter, daughter to daughter, like this. So parent to daughter, daughter, daughter. One can show from parent also different daughter peaks also. Then another way, or this for 57 or for 43, another way, that is a positive breaking of this side bond, left hand side of that plus dot. Here right hand side we break here. Here breaking of left hand side, so positive charge on this carbon with breaking of ethyl fragment. So mass of that fragment is 57, because it is 1, 2, 3, 4, 4 carbon and 9 hydrogen as like previous. From this again you can lose a C double bond C, that is ethene. You will get 29 mass for that ethyl cation. Okay, that's the breaking of this bond, shifting towards this positive, and formation of that positive charge this on this carbon. So you're getting CH2 positive CH3 ethyls with positive charge, and which shows the mass of 29 in mass spectrum. Then molecular ion where positive dot in on third carbon. In this it is shown on second carbon, it is shown on third carbon from the right hand side. Breaking of this bond, that is a middle bond, third fourth bond. So positive charge remain on this carbon or this carbon, same way, because it is a symmetric breaking, and you are getting positive charge, that is 43 here. So this is another way for formation of 43 fragment. In first case, we look, that is the daughter, and first daughter gives second daughter. But here this parent gives direct that 43 daughter peak. Okay, so 43 formation takes place in such in this way also, and this way also. And from this daughter to then again for 15 as above, loss of CH2 CH2 ethene molecule. So breaking from molecular ion parent ion to daughter, daughter will undergo fragmentation, giving new positively charged fragment. Or molecular ion break from another carbon-carbon bond gives that daughter ion split directly. Likewise, so this is a fragmentation for hexane. This hexane is used, where this hexane used. Yes, anyone? This hexane is used where?
As a solvent.
As a solvent where? So
TLC.
in TLC you use that hexane. So that is the
Yes,
fragmentation of hexane here.
hexane.
Okay, next slide. Fragmentation of branch alkane. Now we look up to that straight chain. Now branch alkane. The same fragmentation takes place branch, because if branching is increasing, stability of formation of cation is increasing. So to break in a such way that the more stable cation will form. Okay, here branch alkene genesis for 2-methyl pentane. Okay, give the genesis for 2-methyl pentane. M by Z given 15, 29, 43, which is 100%, that is base peak, 71 and 86. So immediately calculate its M by Z. of a molecular ion peak, because sometimes molecular ion peaks is not given in this m by z, or sometimes it is given, depend it is given or not. First calculate. So by calculating that, 1 2 3 4 5 6, it is having 6 carbon, like hexane. Same, it is a isomer of hexane, branch alpha constitutional isomer of hexane. So same C6H14, you will get 72 plus 14, 86. Yes. So 86 is M by Z. So first step, from 1 methyl pentane loses 1 electron, and you will get that plus dot, that is your molecular ion peak. Yes. And break now, take that molecular ion peak for each type and break each single bond, carbon carbon single bond. So in first case, if you breaking up this AB pattern and positive charge is going to this carbon, then you are getting that 71 peak. Okay, so that is 86 minus 15 methyl radical will fragment, will loss from this, you are getting 86 minus 15, yes, 71. So 71 fragment you will get. Okay, if you break from this way, you are getting, if you break this way, you are getting positive charge here and dot is here. So that is second way, breaking of that black way. So you are getting CH3 CH CH2 positive and this propyl radical, so you are getting 43. Is it stable? Yes, it is stable because it is a secondary or tertiary cation, and you will get propyl radical. Both are stable, so formation or breaking of this fragmentation is more in number, and more cation will form. That is your 100% more populated peak. So base peak which gives 100% intensity because of large number of fragments formed this way. Then for 15, one can show reverse way of this, because this is positive charge and this is negative charge. One can sorry, dot positive charge, this 15 dot not detected in mass. Then 29 breaking from this way, breaking of this, you are getting positive for this way, 29 negative for this. Okay, so by this way you can show. Or previously, like this positive charge, you bring that double bond here and make this CH2 positive with neutral propene group. Okay, that is the daughter to daughter peak. So you get 29 here, like previous hexane. Okay, so by this way one can show fragmentation. So that is, you're having ox in your hand, you have to break in a such way that you are getting M by Z like this. Okay, is any problem in this? Hello,
No, sir.
any problem?
Sir,
No,
Yes.
sir.
Okay.
No, sir.
Okay. Next question branch. This is for homework for you. Branch alkane, you have to show that base peak form. Breaking for this branch alkane. What is the name of this compound? And molecular weight, that is 170. So it's M by Z for molecular and peak is a 170. It is here, means that is not detected, means formation of this 170 is very less in number because it is unstable or not formed. But 57 is formed in more number. That means breaking of that molecule or fragmentation of molecule takes place in a such way that 57 cation, 57 M by Z fragment which having positive charge is a more stable. So this, if you're looking this CH3 CH3 calculate mass for this 1 2 3 4 carbon, 4 carbon having mass 48 plus. Okay, 48 plus 9 hydrogen. 48 plus 9 hydrogen. So this is 57. So this is more stable butyl cation, which is more stable tertiary cation, and it's showing the 57p. Also from this way also breaking. So both end it form methyl cation, which is the more stable. Then one can show that is the 99, 71, depend which is given in the exam. Then next is the fragmentation of cycloalkane. Alkane, simple alkane, branch alkane, straightforward CH2, breaking of propyl, methyl, butyl, or any that giving positive charge. But in cycloalkane, cyclic structure, so it loses the side chain if present. Okay? The first way in this is the breaking of side chain by alpha cleavage. Then loss of ethylene or double bond fragment from the ring, as previously we break that daughter to daughter by loss of CH2 CH2. Here once the form molecular ion peak form that one can break to daughter by losing the CH2 CH2, that is double bond fragment. And cleavage takes place by homolytic fission, that is single headed arrow you have to show for breaking of this bonds. If you showing homolytic, you have to show single headed arrow in the mechanism. Example for this cyclic alkane, fragmentation of cyclopentane. Cyclopentane having molecular formula C5H10, because the ring is present, two hydrogen loss. So C5H10 cyclopentane. Immediate calculated mass, its mass is 70 molecular weight, and when you bombard with electron, it loses one electron, getting positive and dot. So its molecular ion peak m by z 70, that is your m plus peak. M plus peak is a 70. Okay, so that is the first step of every problem, every genesis formation of molecular ion peak. You have to calculate its molecular weight and m by z of that m plus peak. Then second step, from that molecular ion you have to go to second step or other steps from molecular ion peaks. Here it is your molecular ion peak, and let's take the breaking of this bond. Okay, first breaking of this bond, first dot. Okay, so breaking gives the same m by z because none of loses from that fragment. So breaking takes place due to cyclic in nature. All positive and dot remain in a same fragment. So that is also same your like a molecular ion peak. Positive goes to one carbon, dot goes to one carbon as previous AB type pattern fragment. So positive were written for this carbon, dot is written for this carbon, and this radical undergo elimination of CH2, that is this single headed arrow, this is single headed arrow making double bond, and this single headed going down, you're getting dot radical here. So that dot radical is of C3H6, and which is showing m by z 42 here and loss of 28. So from molecular ion, if you lose 28, you will get 42p. So how it is loses? It is losing from this way. That is a single-headed from dot. That is like your photochemistry. In photochemistry, you show that single-headed arrow mechanism. Here, show that single-headed arrow mechanism from radical. Okay, so breaking of this and dot positive, and if it is positively charged, it detected in mass spectroscopy. So that m by z for this fragment is C3H6. Are you getting? So that is a fragmentation of simple cyclic compound. Okay, it is not substituted. It's a simple cyclic CH2, 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 CH2 like this. So breaking takes place. Breaking first step form molecular ion peak, and once the molecular ion peak break any carbon bond, after breaking you are getting same m by z because none of undergo fragmented from molecule due to cyclic structure, and from that plus dot which is having on different carbon undergo breaking of this radical to form ch2 ch2, and this plus dot on this facet C3H6 giving M by Z 42 here. Okay. So every cyclic compound, simple alkane, cyclic alkane undergo this way fragmentation. So next, hexane, cyclohexane, which is famous compound in, in point of view of stereochemistry. Cyclohexane from TY level, you are heard about that. Cyclohexane, substituted cyclohexane. Now in the mass spectroscopy, so molecular formula for cyclohexane C6H12. Okay. So after molecular formula calculate is molecular weight. So C6H12 72 plus 12 is 84. So its molecular weight is 84. First step always to make a molecular ion peak. So molecular ion peak is having 84 only, and by Z you are getting peak at 84. That is your molecular ion peak. After formation of molecular ion peak, breaking of any carbon-carbon bond. So let's break this one. So positive go one carbon, dot go to one carbon, but still it is having same M by Z because none of lose from that molecule. Only bond is break in separate. Now once the radical form, undergo this breaking of radical to form a CH2 neutral molecule plus this one, that is plus and dot here. So C4H8 you are getting this, and its M by Z is a 56. You have to calculate how many carbon. This is CH2, that is C4H8, and C4H8 having M by Z 58, and plus that 28 will lose here. Another way for this cyclohexane, that is breaking off here, that is breaking of this bond will take place by homolytic. One electron goes to this way, one electron go to this way, and you are getting this positive and dot. Okay, so homolytic way you can show here, one electron go to this, one electron go to this, and this positively charged which is detected in your mass. So plus CH2 and dot you are getting here. It's M by Z is a 46 C3S6. So that is the fragmentation in cycloalkane. Direct one can show, or one can show direct here, making of cyclopropane compound type in like a photochemistry, and this dot plus on one fragment. So those who having positive charge with dot or without dot, they are detected in mass spectrum. So that are showing peak M by Z on 42. Is that clear, or having any doubt in this? Yes. Any doubt in this cyclohexane? Hello?
In the last step,
Yes.
the third step, the bond will break.
Yes.
So we will get C3H6 like these. We will get two molecules.
Yes. So second molecule not shown here because it is a dot dot. So dot dot will not detect in mass.
Okay. So I
Only
mean, the second one will be only a radical, no charge on it.
yes, no charge. So no charge particle or fragment will not detect in mass. Only positively charged will detect in mass. So second is not
Okay,
shown.
okay.
Any problem? Yes, any other? Okay. Next problem. That is a cyclic compound with methyl substituent. Second is genesis of one methyl cyclopentane. Methyl group is attached to that cyclopentane ring. So first step is the making of molecular ion. For each and every compound in mass spectrum, you have to make the molecular ion pair by losing one electron. So here bombardment of electron loses one electron to get a dot and plus. So that is a molecular ion of 84. like a cyclohexane, same molecular formula of cyclohexane, and that 1-methyl cyclopentane, C6H12. Then alpha cleavage or that side substituent break first in this way. So this methyl will break, methyl getting dot and cyclic ring getting positive charge like AB pattern, AB type of pattern. So methyl having 15 mass, so molecular ion minus 15, that is 84 minus 15, you will get 69 peak, 69 peak in this molecular spectrum. Then another way, that is if these methyls are not break any bond of this ring, another way, so that is breaking adjacent to that methyl group here. If you break that methyl adjacent bond, you are getting plus dot here. So plus is written on methyl because it is giving stable cation and radical to that, and it is having same M by Z as like a molecular ion because none of loses from that fragment in during that uh, breaking. Now they once this radical form, that radical undergo elimination of CH2 CH2, okay, beta elimination like. So this radical come to form double bond with this carbon radical, and this one electron goes to other. So you're getting plus and dot on this molecule, which is having molecular formula C4H8 and having mass M by Z is equal to 56. So you have to calculate C4H8, count the carbon and hydrogen, and write down their mass. M by Z is equal to how much? 56 plus 28. Or you can lose that 28 from molecular ion, you will get 56. Okay. Both way you can calculate for that, or you can minus this 28 from your parent. But condition is your carbon will satisfy all this fragmentation. So we have fragmentation for 1-methyl cyclopentane. Next example, genesis for 1-methyl cyclohexane. Cyclohexane we are taking, and it is similar to that of previous example, methyl pentane. Here methyl hexane, one carbon is extra. So first step, same molecular ion formation, bombardment of electron. One of the electron will loses from molecule to get a molecular ion peak M plus. Sorry, here plus dot. So this having molecular formula C7H14. So C7H14, 7 into 12, 84, 84 plus 14 hydrogen. So 84 plus 14, you will get 98. So M by Z for molecular ion peak is a 98. Now second step, if it is having substitute, then break that substituent. Here methyl is a substituent. Break that methyl by AB pattern. So here you are getting CH3 dot and this ring getting positive charge because it is a stable. Reverse way you can do CH3 positive and ring. So for 15 you can write that fragmentation if asked it is. Okay, that is first you are getting 83. Reverse way also can write dot and plus here. Okay, that is 15 fragmentation. Here it is shown 83 fragmentation. Then second, break this ring. That is a side chain or side substituent. You break, you are getting 83. You break here, that is a bond which is adjacent to side substituent, that is methyl substituent, because so dot goes to that carbon, plus goes to substituted carbon because this is a more stable cation. And after follow CH2 CH2 lose by single headed arrow mechanism, and you will get C5H10. C5H10 you will get that 70 M by Z 70 fragment. Then reverse way one can show like this. Breaking up this molecular ion in this way, positive goes to this carbon, dot goes to this methyl substituted carbon. Then breaking of side CH2 CH2, that is here propene is formed, and making of this plus dot, you are getting mass M by Z for this is 56. So that is a pattern for cycloalkane. One side substituent you have to break, Here CH3 given. In another example, it is given ethyl methyl propylene. You have to break that and make this. So AB type, you have to break AB pattern or BA pattern. A getting positive charge in first and B getting positive charge in second. Then for cyclic alkane, you have to break ring from any carbon. Here we are breaking adjacent to substituent because positive or dot we can write do that substituted carbon. So this third step, that is positive on substituted carbon. Fourth step is a positive on radical on that substituted carbon, and then write down how many carbons that fragment having and calculate its M by Z. So that is the M by Z for that fragment. So that is genesis for cyclohexane, methyl cyclohexane. Is any problem? Hello. So follow the steps, you will get the fragment. Okay. So which are the steps to break down this fragment? Okay. Any problem? Hello.
No, sir.
Okay. Next is the fragmentation of alcohol. Time left. Hello.